So we'll continue our discussion on Jaya effect regarded to a mathematics 1 to infinity. So we are looking at the issue of calculus, the foundational issues that given an infinite series, how such a series can get different values. We are looking at that series, such a series, and how analysis will develop to solve this problem. So we are looking this series, and we say it can be 1, it can be 0, it can be 1, or it can be half. Okay, so naturally this problem has to be fixed. So they came with an idea of partial sum and convergence. So in this case, we consider a partial sum. If you look at the partial sum, S1 1, S2 0, S3 1 0. So the partial sum bubble back and forth. So this series does not converge. It's not a convergent series. So it has no definite convergent value. Whereas there can be infinite series which converges. So they develop the concept of partial sum and convergence concept. But still there are issues involved. So you consider this series 1 minus half plus 3 minus 1 by 4 1 by 6. Here actually what happened is partial sums doesn't oscillate. They keep on. The partial sum is instead of one step forward, one step backward, the steps now get progressively smaller. If one step forward but only half a step back, then a third forward and fourth step is back. Notice the pattern. The fractions with odd denominators have plus sign in front of them, while the even fractions have negative sign. The partial sum in this case is 1.0, 0.8. So now if you go far enough, you will find that they home in on a number close to 0.6. There is a concept of convergence. It goes up and down. But the problem is this can be arranged differently and to give different values, like we did in the initial series 1 minus 1 plus 1 minus 1. Even though it looks converging, there is a convergent value, still it can be shown to be weird. Rather than prove that, it will let us look at particularly simple arrangement. If we arrange like this, 3 terms, and then you get the smaller one, then you get something like this. Okay, that will be half log n to 0.6. That means let us look back. So it's strange, sick. But the point is why you want to discuss the curves. It is not like this. These curves we get into signal analysis, digital photography, MRI, all those things. Basically, why we are into substantially it matters in real life too. As we have seen throughout the book, even the most abstruse, far-fetched concepts of math often find application to practical things. The link in the present case is that an impact on the science and technology, from signal processing, acoustics to finance, medicine. It is useful to represent various kinds of curves, sound and signals as images of some are simpler curves and sounds. Something like this. F of x sin x minus half sin 2x, that kind of. And this pattern comes like this. So here actually the partial sums, how discussion study of the partial sums become important. Thank you.